Hi, this is Suresh. Welcome to Rock Tutors. Today, we are going to discuss about ray diagrams of concave and convex lens. In the previous video, we discussed about principal rays and kind of images. If you understand the concept, then today's session, it is very easy to understand. If you didn't see that video, please go through the video. You understand the concept of the principal rays. So now, without any delay, we will start our సెషన్. ఈరోజు మనము రే డయాగ్రామ్స్ గురించి నేర్చుకుందాము. రే డయాగ్రామ్స్ ఎలా డ్రా చేయాలి, అలాగే ఈ యొక్క రే డయాగ్రామ్స్ డ్రా చేయడానికి ఇంతకుముందు వీడియోలో మనము ప్రిన్సిపల్ రేస్ గురించి డిస్కస్ చేసుకున్నాము. ఆ యొక్క టాపిక్ అర్థమైతే ఈ యొక్క రే డయాగ్రామ్స్ డ్రా చేయటము చాలా ఈజీ. సో మనము టాపిక్ లోకి వెళ్దాం. అవర్ టాపిక్ క్యారెక్టరిస్టిక్స్ అండ్ లొకేషన్ ఆఫ్ ఇమేజెస్ ఆఫ్ కాన్వెక్స్ లెన్స్. టు డ్రా ద రే డయాగ్రామ్స్, in the previous video we discussed about principal rays. So there are three principal rays. This is the optic center, this is the F2, 2F2, F1, 2F1. The ray is parallel to principal axis. After refraction, it will be pass through focus F2. If the ray is passing through optical center, so refraction without any deviation, it will go straight. Is that another ray? If the ray is passing through focus F1, after refraction, it will be parallel to principal axis. We discussed about these three rays. Now, today, by using these rays, we will draw the ray diagrams. So, one by one. For a convex lens, there are 6 cases. For concave lens, there are 2 cases. We will do one by one. Case 1. When object is at infinity. To draw the ray diagrams, carefully observe. We label the points. This is the optic center. This is here, this side is a F1 and this is 2F1, F2, 2F2. So here the distance between optic center and F2, your optic center F1, both are equal distance. Suppose from here to here this is a 10 centimeters, then this also O2 F1 also 10 centimeters, and here also F2 and PF2 also same distance 10 centimeters, and here also from here to here also 10 centimeters. And you have to draw the one more line as the middle of the lens. Why? Because the ray after refraction, so because these lenses are very thin lens, so that's why here only one time to be refracts. When object is at infinity, the rays all rays are parallel to principal axis. When object is at infinity, parallel to principal axis, after refraction, this ray is passing through focus. And take one more ray parallel to principal axis. After refraction, it passes through focus. Where the image forms? When the rays are refracted, after refraction, where the rays are meeting, there the image will be formed. Now, in this case, after refraction, they are meeting at focus. That means here that image is formed at focus. And see the size of the image. Size of the image is a small size, is a point size. It's called a highly diminished. And nature of the image, a character of the image. What is the character of image? Now see here, these after refraction, these rays are meeting. They are really meeting at a focus. So when after refraction, refracted rays meeting, means it is they are meeting really, that's why it is a real image. Character of the image is real. And real images always inverted. So now this image is real and inverted. This is the character of this image. Where is the position? Position at focus. Character real and inverted. Size. Size of the image is a point size, highly diminished. Application of this lens. This lens we apply for a burning glass. Now, one more case we'll see for this. Suppose same lens, object is at infinity only. If the rays are obliquely falling on the lens, then where the image forms. We'll see. Now here these rays are parallel but not parallel to principal axis. This is called a oblique rays. Now obliquely they are falling on the convex lens. After refraction, so you know this ray is converge and passing like this. For this, I'll draw a focal plane. Focal plane means an imaginary plane perpendicular to principal axis and passing through focus. Now this ray, we know that this ray is passing through optical center, means it will not deviated, this is undeviated. Now this ray is passing through focus. At refraction, it will be parallel to principal axis. Now here the image is forming here. Where the image is forming? At focal plane. This is a special case. So here also both are same, but in this case image is forming at focus. In this case, image is forming on focal plane. Size is diminished. This is the regarding case 1. Case 2, when I kept the object beyond 2f1, then how the image will be formed, we'll see now. I kept this object beyond 2f1. and I'm taking a ray parallel to principal axis. You know that a ray is parallel to principal axis means after refraction it will pass through focus. Yeah, the ray is parallel to principal axis. After refraction it is passing through focus. Second, I am taking the ray is passing through focus. After refraction it will be parallel to principal axis. Yeah. Now see, this ray is passing through focus. After refraction it is a parallel to principal axis. Now these two rays, these two refracted rays are meeting here. Now here that image is formed. Now this is a real image, and if you observe here, this is a inverted, and we'll see the size of the image. Now here size of the object height is 10 centimeters, and here image height is 5.1 centimeter. That means compared to object, size of the image is diminished, smaller means diminish. And position of the image, where it found? It is found between F2 and 2F2. It's found between F2 and 2F2. So we clearly you can observe here. Position between F2 and 2F2. Character real and inverted. Size of the image is diminished. Application of the image. So application of the image, where we apply this one? Apply in the camera. You know that in the camera it's captured that image. That's a big size of the objects. It captured in a small size. That's why we use this lens in a camera. Case 3, when object is at 2F1. Object I am keeping at 2F1. At 2F1. Now I am taking a ray parallel to principal axis. We know that this ray after refraction it passes through focus. Yes, this ray is parallel to principal axis, after refraction passing through focus. Another ray I am taking, a ray is passing through focus, after refraction will be parallel to principal axis. This is the ray. Now both are meeting here. Now here that image is forming. So where the image is forming? At 2F2. At 2F2. And this is a, you can see that this is a real image and inverted. What about size of this image? Now see here, in this one, object height is 10 centimeters and image height is also 10 centimeters. Means what? When we kept the object at 2F1, that image formed at 2F2 and size of the image is same as the object size. Position at 2F2. Character real and inverted. Size same size of the object. Application where we apply this lens. Terrestrial telescope. So in that we will apply this one. Now fourth case. I am keeping object between 2F1 and F1. Now what happens? I'm taking a ray parallel to principal axis. Another ray I'm taking, this ray is passing through optical center. When ray is passing optical center, we know that it will not deviated, it will be undeviated, it will go straight. We'll see now. If you observe here, this is the ray is passing through optical center, it is undeviated and is going through straight. Now here that image is formed. Now image is formed, where the image formed? Beyond 2f2. See here, this is after 2f2. So beyond 2f2 image formed, and this is a image is inverted and it's a real image, real and inverted. Size of the image. See size of the image. Now here object size, height of the object is 10 centimeters and image height is 18.8 centimeters. Means compared to object, size of the image is increased. It's a large. This is called a magnified. So when we kept the object between f1 and 2f1, we'll get the image beyond 2f2 and the large size, magnified size. Position beyond 2f2, character real and inverted, size is a magnified, application of this lens, slide projectors, use this type of lenses. Now fifth case. Now I am keeping the object at f1. I will see that how that image will be formed. I am taking a parallel to principal axis. You know that after refraction it will pass through the focus. So one more ray I am taking. This ray is passing through optic center. This ray is passing through optic center. These two are parallel, and you know that this image will be formed at infinity. And this is also real image and inverted, and size is highly magnified. Position infinity, character real and inverted, size highly magnified, application collimator of spectrometer. Now sixth case. So I am keeping the object between lens and focus, or between optical center and f1. I am taking a ray parallel to principal axis. You know that this ray after refraction will pass through focus like this. And one more ray I am taking. Now ray is passing through optic center. This ray is passing through optic center. Now see here, these two rays are not meeting this side. They are moving away like that. It's a diverging. So now this side we will not get the image. Now if I extended these rays backward, now see here, this ray I am extending backward and this ray also I am extending backward. So they both are meeting here. That here image is formed. Now if you observe here, in this case we'll get that this is these rays, the refracted rays are not really meeting. We are extended backward and they are meeting. They are appearing to meet, but they are not really meeting. So that's why this image is a virtual image. And see this size of the image. Now here object size is 10 centimeters and image height is 22.8 centimeters. Means here we got a magnified image. And behind the object, it is a behind the object, same side of the object, the image is formed. This is the sixth case of the convex lens. So what we observe, by convex lens, so we got a real images as well as virtual image also we will get, depend upon the position of the object. Position of the image behind the object. Character, virtual and erect. Erect means upright. Size, magnified. Application, reading lens. We use this lens for a reading lens. This lens will be magnify the letters. You can easily read that to small letters. So this is about a convex lens. We saw here the convex lens. So convex lens, it forms two kind of images, real as well as virtual also. Now we will see images formed by concave lens. Characteristics and location of images of concave lens. For concave lens, case 1, when object is at infinity, then how the image will be formed. You know that just we discussed, when object is at infinity, the rays all are parallel. Now, when take a ray is parallel to principal axis, you know that after refraction through this lens, it will be move away from the principal axis. Now here also one more ray I am taking parallel to principal axis. After refraction, this also refracts like this. It's a diverging. They are diverging. If I extend this ray backward, because now this side will not get image. Why? Because these refracted rays are not meeting this side. And if I extend it backward, these rays they are meeting here. So when I am extending these refracted rays backwards and they are meeting here. So they are not meeting really. It's appearing to meeting here. That's why. So here that image is forming. This image is called a virtual image. Virtual image is always all are erect. Erect means straight, upright, like this. And size of the image is, you can see that here the point size, like is a highly diminished. Where is forming the image? Image is forming at focus. At focus, at F2. At focus, the image is forming. In another case, suppose the rays are falling obliquely. Suppose these rays are falling obliquely, that means parallel but not parallel to principal axis. What happens? Now suppose this ray is passing through focus, we know that after refraction it will be parallel to principal axis. Now this is this ray is passing through optic center, it will not deviated, undeviated is passing, going like this. Now this ray is, we know that this is a moving away from the principal axis. Now this side the image will not form, we know that. Now if I extend it backward and dash, now here, now this is, I am extending backward and these are some extending backward. Now if I draw here, this is a focal plane. So on this focal plane, that image is forming. Position at focus, character virtual and erect, size highly diminished, and application, where we apply this one. So we apply this type of lens in a Galileo telescope. Second case, if I keep the object other than infinity. So already first case we kept that object at the infinity. So now the second case, other than infinity at any place. So then where that image will be formed. Now see here, this is the object I took here, I kept here, and I am taking a ray parallel to principal axis. Ray is parallel to principal axis. After refraction it is going like this, and if I extend it backward and this ray is passing through focus. So one more ray I am taking, a ray is passing through optical center. Yeah, ray is passing through optical center. You know that the ray will not deviated, it goes straight. And now if I extend it backward, this rays, these both are meeting here between lens and the focus. Now here, this is the, here is the image is forming. Now this image is a virtual image, and the image formed between lens and the focus. Nature of the image is, character of the image is, state of nature, virtual and erect. Position of the image between lens and focus. Character, virtual and erect. Size, diminished, small size. Application. So we use this one in a spectacles. This is about the concave lens. The concave lens, if you see here, the concave lens, the object is moving towards the lens. Here, the size of the image is increasing. Size of the image is increasing. But in all cases, the size of the image always less than the size of the object. So here in all cases the size of the image is diminished, and in all cases that image is virtual image only. I hope you understand this concept. In the next video we will discuss about sign conversions. Sign conversion is also one of the important topic. When we are doing the numericals, that time sign conversions are very, very important. We'll see in the next video. Have a great day.